Okay, in this tutorial we're looking at trigonometric symmetry properties and some worked examples for that. Okay, so the previous video we went through some of the theory. Now in this one we want to go through some examples. So we've got here, if sine of theta equals root 3 on 2 and cos of alpha equals 4 on 5, and both theta and alpha in the first quadrant, we need to find tan of theta, sine of pi plus alpha, okay, and tan of 2 pi minus alpha. Okay, so we'll look at this first one for tan. Okay, so what we need to do is actually we need to do a little bit of work before we can actually get to our tan. Okay, because we're talking about theta. Okay, so remember, the only way we can get to tan from here is using our identity of sine on cos. Okay, but at the moment we don't know what cos of theta is, so we really need to work that out first. Okay, so what we're going to use is our sine squared theta plus cos squared theta equals 1. We're going to use that identity first. Okay, so that way we can say, well, cos squared of theta equals 1 minus sine squared of theta. Okay, which we know is 1 minus, well, sine of theta is root 3 on 2, so we're going to be squaring root 3 on 2, which is going to give us 3 on 4. Okay, so then we can say, well, cos squared of theta is equal to 1 on 4. So cos of theta will be plus or minus a half. Okay, but we know that theta is in the first half. Okay, so we know that we're just looking, in the first quadrant, not first half, first quadrant. Okay, so we've got to be looking at the positive one. So cos of theta equals a half. Okay, so now we can look at tan, because we know tan theta is equal to sine of theta on cos of theta. And again, we know that sine is equal to root 3 on 2. Okay, I'll just write this way, divided by cos, which is 1 on 2. Okay, we would flip and multiply, so we'd flip this one up, our 2's will cancel out, so we'll get tan of theta equals root 3. Okay, for the next one, B, okay, we're looking at trying to find sine of pi plus alpha. Okay, so again we're going to use the same identity. We're going to say that we've got sine squared alpha plus cos squared alpha is equal to 1. Okay, and so we can say that sine squared alpha is equal to 1 minus cos squared alpha. Now remembering that cos is equal to 4 on 5, so cos squared, okay, is going to be 16 on 25. 1 minus 16 on 25 is going to be 9 on 25. Okay, so that's our sine squared of alpha. Okay, well, so that'll mean that sine of alpha will be plus or minus, we're going to take the square root of this, okay, 3 on 5. And again, because we know that we're in the first quadrant, okay, it's going to be our positive 1, okay, because sine is positive in the first quadrant. Okay, so we're not quite there yet, we're almost there. Remembering that sine of pi plus alpha, okay, that's in our third quadrant where we know that sine is negative, so it's the same as negative sine of alpha, it's going to be negative 3 on 5. Okay, so sine of alpha, okay, is negative 3 on 5. Okay, our next one here is tan of 2 pi take alpha. Okay, so what we need to do, okay, is look at what that identity, what our basic definition of tan is. Okay, and that's going to be that it's sine of 2 pi minus alpha over cos of 2 pi minus alpha. Okay, well, sine of 2 pi minus alpha is equal to negative sine of alpha, okay, over our cos of alpha. Okay, well, we know that we're looking at sine of alpha being -3 on 5. Okay, we found that out just a minute ago, didn't we? Okay, sorry, that we were looking at, sine of alpha was +3 on 5. Okay, we changed it around afterwards, +3 on 5, so make it -3 on 5. Divide by cos of alpha, which we know is 4 on 5. Okay, flip and multiply, our 5's are going to cancel out. We're going to get -3 on 4 as our answer. Okay, now we've got a couple of other worked examples to have a look at too. That's some exact values as well. Okay, so we're having a look now at finding the exact values of some of these other ones. So we've got cos of 2 pi on 3, tan of 7 pi on 4, and cos of negative pi on 6. So we'll start our cos of 2 pi on 3. Okay, so 2 pi on 3, okay, if we think of our unit circle, okay, this is our pi on 2, this is our pi. Okay, 2 pi on 3 is going to be in here. Okay, so we find that by doing pi minus pi on 3. Okay, so we realise then, okay, remember our cast. Okay, only sine's positive in the second quadrant, which is where we're looking at, so cos will be negative, so we can say that's equal to negative cos of pi on 3. Okay, and we know from our exact values, okay, that cos of pi on 3 is equal to 1/2, so our answer will be -1/2. Okay. For our next one, tan of 7 pi on 4, okay, we need to think about where 7 pi on 4 is. Okay, for our unit circle, okay, come around here, so remember we're 0, pi on 2, pi, 3 pi on 2. Okay, 7 pi on 4 is actually going to be over here. Okay, because our 2 pi would be 8 pi on 4. Okay, here's another way of thinking of 2 pi. So our 7 pi on 4 is around here. Okay, again, remembering with our cast, okay, tan is going to be negative in the fourth quadrant. So really we can say, well, tan of 7 pi on 4 okay, is really tan of 2 pi minus pi on 4, because we're in the fourth quadrant, that's how we find our angle. Okay, tan is negative in the fourth. Okay, so we're going to get tan of 7 pi on 4 equaling negative tan of pi on 4. Okay, and tan of pi on 4 is 1, so we're going to be -1 as our answer. Okay, our last one is cos of negative pi on 6. So we're negatives, that means we're going backwards, okay, for measuring our angle. So instead of measuring this way, we're going to measure this way, okay, by pi on 6. Okay, now remember again with our cast, okay, cos is positive in the fourth quadrant, okay, which is where pi on 6 is going to be. Well, our identity also tells us that cos of negative theta is equal to cos of theta. Okay, because of this idea we're in here, so really cos of negative pi on 6 is going to equal cos of pi on 6. We know cos of pi on 6 is equal to, cos of pi on 6 is equal to √3 on 2. Okay, so there's just a few examples of how we use our knowledge of our symmetry properties as well as our knowledge of the unit circle to answer some basic questions. So hopefully that will be enough to get you through any of the questions you need to do.